In this tutorial, we will be discussing the types of solutions, primarily as a review, and the solubility. A solution is a homogeneous mixture, also pronounced homogeneous, whose components are solute and solvent. Notice that when we added salt, which this is seawater, so this is salt water, the salt broke down into its components of Na plus ion and chloride ion, whereas the water stayed by itself as a whole. Notice that there's also several more water molecules than there are ion particles. The solvent is a greater quantity than the solute. I mentioned before that the salt broke down into sodium and chlorine ions. This is called ionization. Miscible and ionization are not the same thing. If something is miscible, that means the solute dissolves in the solvent as a whole unit. It doesn't break apart. It does not ionize. Where ionization, the solute dissolves in solvent into pieces or ions. Immiscible means that the solute and the solvent do not mix at all, such as oil and water. The solution does not form. Solutions have variable composition, and it's described by its components, the solute and the solvent, and their relative amounts. The terms dilute and concentrated are qualitative descriptions of the amount of solute in a solution. Dilute would be a small amount of solute, while concentrated is a large amount. A solution's concentration is the amount of solute in a given amount of solvent to make the solution. A solution is a homogeneous mixture or homogeneous mixture of two or more substances. Solutions can be composed of same phases or different phases. When we're referring to phases, we're referring to physical states, such as solid, liquid, or gas. So in other words, a gas can be dissolved in a liquid, even though they're in different phases. One constituent is usually regarded as a solvent, which is usually the larger amount, and the other is solute, which is the smaller amount. The ability of a solute to dissolve in a solvent or its solubility depends on the following factors: nature's tendency towards mixing, which is in thermodynamics, and the types of intermolecular attractive forces, such as ion-dipole, dipole-dipole, hydrogen bonding, things that we've talked about previously. Solvents and solutes must be compatible, otherwise the solution will not be formed. In other words, they have to have similar polarities. Nonpolar compounds will mix with nonpolar compounds, and polar compounds will mix with polar compounds. An unsaturated solution contains below the maximum quantity of solute that dissolves at a given temperature and a specific amount of solvent. Notice that the terminology of specific amount. We want to be able to look at ratios when we're looking at concentrations. If we talk about two different amounts, but we have two different amounts of solvents as well, then it's a lot harder to compare. Once the rate of dissolution is equal to the rate of deposition, so in other words, it dissolves as fast as it recreates the crystals, as crystals are formed, the solution is saturated with the solute and no more solute will dissolve. A saturated solution contains the maximum quantity of solute that dissolves at that temperature for a given quantity of solvent. And a supersaturated solution can contain more solute than possible for any given quantity of solvent and are unstable. Supersaturated solutions are unstable and lose all their solute above the saturation when it's disturbed. This down here is a picture of a supersaturated solution. It looks just fine, but once it's been touched, right here, the crystals start to form, and anything above the saturation point will fall out of solution. Other factors affecting the ability of a solute to dissolve in a solvent are the temperature, pressure if it's a gas, and the ratio of the volume of solvent to the amount of solute. Solubility is generally given in grams of solute that will dissolve per 100 grams of water, which is the solvent. notice once again in 100 grams, because that's the given amount. If we have a standard, it's easier to compare. This is a solubility curve. Once again, notice 100 grams of water. So this is how many grams of the substance will dissolve in 100 grams of water. And the temperature increases from left to right. And you'll also notice that as the temperature increases, the solubility changes as well. The solubility curves are used to predict whether a solution having a particular amount of solute dissolved in water is saturated. So if we look at KCl, for instance, if it's on the line, it's saturated. If it's under the line, down here, it's unsaturated. If it's above the line, it's supersaturated. We can use this to determine the solubility. Determine for each of the following whether the solution is saturated, unsaturated, or supersaturated. So let's look at KNO3, 50 grams of KNO3 for every 100 grams of water at 34 degrees Celsius. So here's 30, here's 40, be somewhere around there, and we're looking at 50 grams. There's 50 grams. It actually looks really close to it being on that line, so what I'm going to say is right on the line there. So that's going to be saturated. If we're still looking at 50 grams, but now we're looking at 50 degrees Celsius, you notice it's now under that line, so that means it's unsaturated. Let's stick with KNO3. 50 grams of KNO3 for 50 grams of water. But this is in 100 grams of water. Therefore, we need to convert this to 100 grams so that way we're able to compare it with the chart. So we're going to multiply that by 2. If I multiply that by 2, that means I have to multiply this by 2 as well. So that means 100 grams of KNO3 at 100 grams of water at 50 degrees. So here's my 50 degree mark. That actually becomes a supersaturated solution. Finally, 100 grams of NaCl, we're looking at NaCl this time, for every 200 grams of water. Once again, this is 100 grams of water. I need to be able to compare it, so I'm going to divide both sides by 2. That equals 50 grams of NaCl. That equals 100 grams of water, which means I can now use this chart. So 50 grams of NaCl at 70 degrees. That puts me right here, which creates a supersaturated solution. Alright, and that is how you use the solubility chart.